and let's see what happens on the back. Okay, now, we're still doing patterns, but we're doing patterns with derivatives because some derivatives have patterns. All right? So let's see what we have here. Find the third derivative of the following function. Okay, how in the world am I going to find the derivative of 1 plus 7x to the third? Couldn't I do the, can I bring in the 3? As long as there's not a what? As long as there's not a variable in front, which there's not, so we can do the good old-fashioned, remember what this is called? Chain rule. Chain rule, right. And it's part of the power rule as well, isn't it, right? So you bring the power down, you do the chain. All right, so let's do the first derivative, which is going to be y prime, although you know what? We're going to use a new notation tomorrow, so why don't I go ahead and throw it in today, give you a heads up, all right? There is another way to write y prime. You may also write it as dy over dx. Y prime is easier, definitely. Okay. My next point is usually just write y prime. But there are a couple of problems we'll do in calculus where you cannot do them unless you write it as dy dx. So future heads up. Okay? But you can write this as well. All that means, it means take the derivative of the y equation, so you know which one to use if there are multiple equations. So take the derivative of the y equation. And the way that you read this is with respect to x. Okay? So dy over dx is derivative of y with respect to x, because isn't x the thing that actually goes through the derivative process? Right? Not the y, you just put a prime on the y. Okay? So just kind of remember this for the future. Now the derivative would be 3 at the front. Inside would stay the same. Okay, so the new power is 2. And the chain rule is 7. What do we usually do? 7 times 3 is 21 consolidated, but not today.
What?
Not today. It's tempting, because we're used to it, right? Today, we're looking for patterns. So if we're looking for patterns, don't combine things because you'll lose sight of the pattern. You want to leave it all just written out. Okay? Just keep it all there. All right? Next one. Let's see what happens.
Coach Wade?
Yes?
Could you send Taylor Peck to the office conference room, please?
Sure.
Thanks.
He's on his way.
Bye, Steve.
You mean Steve Peck? Okay. Just cut that out there. All right.
Should have told her. Steve Peck?
Yeah. Steve Peck?
No.
Okay. So, let's see. Have we ever done a double derivative before?
Yes.
I think we have somewhere, haven't we?
No, that was a triple.
It was a triple. Okay, yeah. So, okay, it was a bonus. That's right. Yeah, okay. So when you do the second derivative, that's just the derivative of the first derivative. Does that make sense? Okay, all right, yes. So put 2 primes, because that's y double prime. All right? Or, the fancy notation, which we'll use tomorrow, is d squared y over dx squared. That is the double derivative. All right? Okay, either one's fine. This one's easier, but in the future, you're going to need this one a couple of times. Right? So, when you do the next derivative, don't make that 21. Just kind of think it's 21 in your head. If that really is 21, and you do the next derivative, so the coefficient.
42.
Well, yeah, but at first the coefficient does what when you take the derivative? What is the coefficient when you take the derivative? Doesn't it just
drops down?
It just drops down, doesn't it? Yeah. So the 3 is still there. The 2 comes down to join it, but don't make it a 6. You'll lose your power. Just make it 2 times 2. Okay? Don't simplify anything here. Right? 1 plus 7x stays the same. What's the new power? 1. Now that 7 is already here. But by the chain rule, doesn't another 7 come out? So it's times another 7. Okay? You are actually seeing the pattern of the chain rule without simplifying it. You're seeing it behind the scenes. Right here. Okay? Triple derivative, that would be y prime, prime, prime. Okay? Or d cubed y over dx cubed. Now, don't simplify anything. 3 times 2, that's kind of like a 6, but wouldn't it just drop down? It would stay there and be joined by the 1. The base would stay the same to the 0. That's kind of like a 49. Guess what? It stays right there, doesn't it? But 1 more 7 jumps out and multiplies. Okay? Don't make that 343. It is, but you'll lose the pattern. All right? And that's the third derivative. Now it says write that in factorial exponential form. Factorial exponential form.
3 times 2 times 1.
Wait a minute, 3 times 2 times 1.
Factorial 3.
3 times 2 times 1 in math, isn't that 3 factorial? Okay, remember that in geometry, algebra 2? Algebra 1 here? All right, 3 times 2 times 1 is known as 3 factorial. Anything to the 0 power is 1, drop it out. And 7, we have 3 chain rules, so it's 7 to the, that's the exponential part. And that is the nice pattern of the third derivative right there. Okay? When you break down powers over and over and over again, they get lower and lower, so you create a factorial and you create an exponential. Okay? There you go. Nice stuff. All right? We won't do the fourth derivative, but if you did the fourth derivative, does anybody know what it would be?
Oh, yeah, you would have that.
It's actually pretty simple, simpler than you would think. You think 0?
0 factorial.
You know what?
4.
What happened to the x's? Are all the x's gone?
Yeah.
So that's just a number. That's just 343 times 6. That's just a number. If you take the derivative of a number, you get 0.
Bam.
So the fourth derivative is 0. So it all just collapsed eventually. And then the derivative of that, the fifth derivative, is 0. And the sixth is 0, 0, 0, 0 forever.
I like that.
Is
Is that because the slope eventually happens out?
Yes, very, oh, very nice. Wow. Jillian, so smart. Stephanie, very nice. I'm going to put a plus 10 to Comiskey right over here.
Is that because the slope like eventually flattens out?
Yes. There it is.
Wow.
Hey, that's thinking right
You
there.
guys have cute
All right, so let's go to F. All right, 101st derivative. Good night, Mr. Wade. You want me to take 101 derivatives?
Find that pattern.
That's going to take a long time. Do we have time to do that?
No, really, no.
But there's a shortcut. Here's a shortcut. Okay, first derivative of sine of x is? Yeah, it's cosine of x. What's the chain rule?
1.
Oh, it's just times 1, right? Forget about it.
Oh, get back.
All right, second derivative.
I need a sign of X.
It's going to be negative sine of x times the chain rule of 1. Third derivative,
Negative cosine of X.
negative. Remember that sine derivatives stay the same sign, right? Okay. Now, before you write the notation for the fourth derivative,
Just 4.
it's special, okay? You don't want to put 4 primes. When you get to 101, do you really want to put 101 primes?
I'll do it.
You just
No,
put
no,
all
no.
ones.
Somebody has done it before, once. All right? Once in 15 years, okay? Don't do it, because it took up the whole page. All right? So, you don't want to write 101 primes. Here's the trick. Once you get to 4, you just put the number 4 up there. Wait a second. It looks like why to the 4th? We already used that for something else.
Put a
I'll-
prime in front of it.
If you actually, oh, that'd be clever as well. Actually, what they do, they just put parentheses around it so that you know it's not a power, it's just a, oh, okay, that's just a derivative. Excellent. I like the prime, that would be better. I like it.
That's a plus 10.
What?
All.
All right, that's absolutely. But you never thought of that, I guess. Okay, so once you get to the 4th, just do parentheses and keep going. So the derivative of negative cosine is
Sine of
what?
X.
Sine of x. All right, let's do the 5th derivative.
Why?
What is the derivative of sine of x?
Cosine of X. And we reverse.
Wait a minute. Wait a second.
That's where we started.
Yeah, it is, okay? Don't include this in your pattern. Never include the original function in your pattern. That's step 1, 2, 3, 4. It's like a sequence. It's like a series. 1, 2, 3, 4. Okay? So, the derivative of sine is right back up here at cosine. How about that? And the 6th, and the 7th, and the 8th, right? So it goes in cycles of 4. So, the 8th is right here. 9, 10, 11, 12. That's right here. 13, 14, 15, 16. How do we get to 101?
Divided by 4.
Okay? Yeah, so how close can we get? Yeah, 100 is a multiple of 4. So the 100th derivative would be on this level right here, right? Every 4th derivative is right here. Now you can count by hand. 101 would be the top again. And your 104th derivative is cosine x. And you don't even need 101 derivatives. You just need 4. You like that? Pretty nice, huh?
Yeah.
Oh my gosh.
Better hurry.
Look at that time.
Thank you.
We need a countdown timer at the bottom of each that shows how much time's left. Will they pull it off? We have 2 minutes left.
2 minute drill.
That's right, exactly. Okay, now, this one is pretty much the same thing.
Sort
that
of
a
die
six?
once in a while.
That is a G.
Ah,
Which way is G's? Okay, so we have to do the 33rd derivative. Okay, same thing. First derivative is what?
Negative sign.
Sine
Negative 3
of
times
3x
times
times, now the chain rule is different about this one, times 3. Okay, derivative of negative sine is negative cosine of the same thing. That 3 already carried down,
times 3 times.
but another 3 jumps out of the chain rule, and you have 3 times 3 now, 3 squared. Third derivative,
Sine.
derivative of negative cosine is
Sine.
sine of 3x, and that's essentially a 9. The 9 carries, but guess what?
Another one jumps
Another
out.
3. Now you have 3 cubed. If you want to write it exponentially, you can write it exponentially.
Let's see that one.
And then all we have to do is go to the fourth, and we should be able to find the cycle. So that's going to be cosine of 3x times 3 to the fourth now, right?
Mhm.
Or you can write them all out. Okay? So how do I get to 33? Okay. This would be, what's pretty close? 32 is a multiple of 4. So wouldn't the 32nd be right here?
Sure.
So that's 32nd. Any multiple of 4 is down here. Then the 33rd would be back to the top again. So it should be a negative sign. We know that for sure.
What can
But after 33 derivatives,
3.
you have 33 chain rules, and it's 3 to the 33rd. Okay? And there's your
No
answer.
homework.
Souvenirs? Souvenirs, absolutely. Oh,
No homework.
oh, sure, no.
No
This is lots of fun,
homework. I'm leaving. Not coming to school tomorrow.
Catchphrase. That's all I'm taught up on that, so.
Yeah, I am still
My road.
Oh.